Good morning to all. Welcome to the next session of 3D surface texture parameters. The last session we discussed about classification of various areal parameters as amplitude height parameters, spatial parameters, hybrid parameters, area and volume parameters, and functional parameters. In this session, we are going to slightly elaborate on these parameters. So first we will have the amplitude parameters, and in amplitude parameters we will consider the arithmetic average SA, and that is corresponding to RA value in 2D analysis. So SA is given as 1 by L1 L2 double integral on L1 and L2 f of xy minus f dash dx dy. So where we can see that f dash is the height of mean plane, that is the height of mean plane. The plane is constructed instead of mean line, we are constructing mean plane in 3D surface parameters, surface analysis, and L1 and L2 are the extent of sample, that is in two directions, that is we are taking in x direction and y direction. So sampling length in x direction is L1, sampling length in y direction is L2. Then f of xy is the surface height at xy, that is we are making so many grids over the surface, so each point is having a coordinate in xy system. So this f of xy means we are taking so many grids like this, so each and every point we have some surface height, so that height of the surface at each point is given by f of xy. Similarly, we can have the root mean square value, that is SQ. Instead of RQ, we are using SQ, so it will have a formula like this, and the skewness, that is QSSK, is defined by using this equation. We can have kurtosis SQ defined by this equation, both in x and y directions, and 10-point height is given by SEZ as by this equation. So these are the various amplitude parameters used in 3D surface texture analysis. Next is the functional parameters. So the functional parameters are nothing but the parameters can be specifically matched to a given use or function of the parts. So some examples of functional parameters are surface material ratio, then void volume ratio, that is SVR. Void means the surface parts which don't have any material, that is the valley part. Then surface bearing index, that is for friction purposes, frictional applications. Then core fluid retention and valley fluid retention, both are actually used when the surface is a lubricating one. Is how much fluid it can retain on the surface. This picture indicates what is material volume and what is void volume. So the material volume is nothing but the volume of the material above the mean line. So this sum of all these crust material marked like this over the mean line constitute the material volume Vm, and the void volume means the volume of the void space, that is the valley below the mean line. And for example, the functional parameter void volume ratio is calculated by this equation. The void volume ratio is represented by with the VR. The table indicates some common parameters under the various categories. So in this case, from 1 to 4 up to this kurtosis, these are amplitude parameters, and in the next set, the 4 numbers are coming under spatial parameters. So they are a density of summits, texture aspect ratio, texture direction, and fastest decay of autocorrelation. So these are coming under spatial parameters. And the next set is the hybrid parameter, that is RMS slope, mean summit curvature, developed surface area ratio. And the next 6 numbers are representing the functional parameters. So already we have discussed about the functional parameters. As an additional information, we are discussing about some surface finish instrumentations, that is instruments used to determine the surface finish or surface roughness. So mainly we are using stylus methods, and next is the optical methods, and finally the scanning microscope. So these are the various category of instrumentation used to determine the surface roughness. So in stylus method, we know that some instruments, especially the profilometer, tally surf, etc., are coming under the stylus methods. It employs a stylus, otherwise known as a probe, and it will have a transducer and reference, an amplifier, filter or processor, then a recorder or output such as meter or computer. So these are the components of a common stylus instrument. In optical method, the various instruments used are gloss meters, total integrating sphere, diffractometers, interferometry, optical followers. Out of this, interferometry has got greater application. So commonly used interferometers are white light interferometry or otherwise laser interferometry. So these two are generally, optical methods are generally known as non-contact type measuring instruments, and these wide light and laser interferometry principles are used to determine 3D surface texture parameters. And the next is the other instruments. In the other instruments, it is one is SEM, that is scanning electron microscope, or scanning tunneling microscope, STM, or otherwise we are using atomic force microscope for determining the surface texture. Thank you for watching and stay safe.